We are continuing with our 7th chapter, second video, ratios and proportions. In this chapter, we will cover combining and comparing ratios. The question says, if Aman's money to Bimal's money is 5:6 and Bimal's money to Chetan's money is 9:11, can you find Aman is to Chetan without knowing any actual amount? Yes, and by the end of this video, you will do it in 3 lines every single time. Welcome back to Quantum Math. Last video we built the foundation. Today we go up a level. What happens when you have two ratios sharing a common quantity and you need to merge them into one big ratio? And how do you compare or arrange several ratios at once? Let's dive in. First, start with comparing two ratios. How will you compare two ratios? For example, if we have A is to B and C is to D. How will you compare them? We need to cross multiply. You know that A is to B is A by B and C is to D is C by D. So you need to cross multiply AD and BC. So you can compare them and see which one is bigger or which one is lesser. So this side, for example, 1:3 and you are comparing 2:5. So which ratio is greater? How will you know which fraction is greater? You have to write 1/3 and 2/5 and you will cross multiply 5 into 5, 2 3s are 6. Which one is greater? This one is greater. So that means 5 is lesser than 6. So you have to write here 1:3 is lesser than 2:5. Got it? This is how you compare two ratios. Let's test this in one of the exercise problems. Here in the exercise problem, it says that you need to compare 7:9 and 11:16. Same method. How to compare them? You need to cross multiply. So what you need to remember here is cross multiplication only works when you multiply antecedent of first by consequent of second and vice versa. Keep the pairing straight or you will flip the answer. So you multiply this and this, multiply this and this. So easy way is to write in fractions and cross multiplying them. So if you multiply 16 into 7, what you will get? You will get 112 and 9 into this 99. So which one is bigger? 112 is greater. So you need to write 100 greater than. So that means 7:9 is greater than 11:16. Simple. Got the answer? Great. Now, whenever you have got a problem where we have to arrange several ratios in order. For example, 4 to 5 ratios are given and it is asked to arrange them in ascending or descending order. So basically you can't just cross multiply each and everything. Here what you need to do, you need to make the ratios into decimals. For example, if we have to arrange 4:9, 6:11, 7:13 and 27:50 into ascending order. You know ascending, right? Ascend means what? You are moving up. From where you will move up? You will move up from down, from the lower place to a upper place. So you have to start from the least number to the highest number. Okay, starting. So first we need to find the least value here. So basically we can't compare these ratio in this form. What we need to do, we need to write them into fractions first, then into decimals. Decimals up to 2 decimal you can write so that it's easy for them to get the comparison. 4:4/9 is 0.4444 something, 44. 6/11 is 0.54554 or 55 you can write. This is 0.53 and this is 0.54. This is 4.8 something, so you can write 0.55. So which one is the biggest one? This is the biggest, then this, and then this one is the last. So you can write directly the ascending order as 4:9 is the least, less than, then the next one is 7:13, then next comes 27:50, then the last is remaining 6/11. Got it? Great. So this is how you arranged when several ratios are given. So you can do you can do ascending, or you can do descending. Whatever comes, you have to do the same method. Is it good? Clear? Now, combining two ratios into A is to B is to C method. Here, combining two ratios. Now the main event. If A is to B is known and B is to C is known, we can find A is to B is to C as long as B is in common to both. Here, for example, if A is to B is given as 5:6 and B is to C is given as 9:11, find A is to C and A is to B is to C. You have to find this. So here basically what is common here? Common is B. But here B is same. But here what? B value is 6 and 9. 6 and 9. We need to make these two values same. Then only we can get A is to B is to C. This is the basic thing. A very important point or very important step here is to make B common, same number. How will you make it? By doing the LCM. We make it same. 6 and 9. What is the LCM of 6 and 9? LCM is how much? 18, right? 6 3s are 18 and 6 2s are 18. So, $18 is the LCM. So what you have to do, you have to make both of them as 18. How will you do that? By multiplying this by 3, by multiplying this by 2, it will become 18. However, while doing so, you have to multiply everything by the complete ratio by the same number. So now A is to B becomes 5 into 3, 15 is to 18, and B is to C becomes 9 2s are 18 is to 11 2s 22. So now these two are same, right? Here now we can directly compare. A is to B is to C will be 15 is to 18 is to 22, and A is to C, you know very well, A is to C is 15 is to 22. Got it? Yeah. Here we have to make this be same number. That is very important, by multiplying by a number so that the LCM of both should come. Got it? This is clear, right? Now, within 3 lines, we have solved the problem which I have used in the opening of this video, right? Okay. You can, I'll give some example or homework problems on this, and you can do it and put your answers in the comment box. Now, the case substitution shortcut. There is an even faster method when ratios are given as equal fractions or equal products. So the case substitution trick works here. For example, let's do an exercise problem here. If 3a equal to 5b equal to 6c, find A is to B is to C. Find A is to B is to C. How will you do that? We need to assume everything as K. Assume, let the given ratios. Let 3a equal to 5b equal to 6c is equal to a constant which is k. Now comparing everything, 3a equal to k. So what happens? 3a equal to k. What is a value? A will be k by 3. We have got a as k by 3. Similarly, b as k by 5. Similarly, c as k by 6. Now we need to take out LCM of these three denominators, 3, 5 and 60. What is the LCM? 3, 2, 5 and 2 times 15 to the 30. 30 is the LCM for this. So we need to multiply everything by 30. Everything you multiply by 30. Now A becomes k by 3 multiply by 30. This will become 10k. Similarly, B becomes 6 5 so 30, so 6k. And C becomes 6 5 so 30, 5k. Got it? Now when you are finding A is to B is to C, I'll get 10k is to 6k is to 5k. K gets cancelled every time, so the ratio is 10 is to 6 is to 5. This is in the lowest form, no need to reduce it further. So this is our final answer, 10 is to 6 is to 5. Got it? Great. And one more problem of this type. For example, if a problem is given like a by 2 equal to b by 3 equal to c by 6. Find same a is to b is to c. This is very easy. If you have to write direct answer, you can write a is to b is to c is 2 is to 3 is to 6 here. 2 is to 3 is to 6. If it is in multiple choice or any other 1 mark problem, you can directly write a is to b is to c is the denominators 2 is to 3 is to 6. How we'll get, I'll let you know. Same, assuming a by 2, b by 3 and c by 6 as k. What you will get? A by 2 equal to k, so a will be 2k, b will be 3k, c will be 6k. Now if you are comparing a is to b is to c, 2k is to 3k is to 6k. K gets cancelled every time, so 2 is to 3 is to 6 will be your final answer, right? Simple. Now applying the same idea to the expressions here. How? So this K method also works when a ratio is given and you are asked to find the ratio of some other expressions built from the same letters. For example, one exercise problem we will do, you will understand it. If A is to B equal to 8 is to 5, find 7a plus 5b is to 8a minus 9b, 8a minus 9b. So such problems, what you do, directly you have to take 8 every time you take A as 8k and B as 5k. This works every time. I have made a short video also on this. You can go and find it out in the playlist. This is very simple. Why we can do it? Because here k gets cancelled every time. So you can put one common constant to every ratio number, 8k and 5k. This simplifies so many things. So you have to just substitute A as 8k plus 5b is 5k is to 8 into A is 8 into 8k minus 9 into 5k. So what happens here? 54. So 54k plus 25k is to 64k minus 45k. So this becomes 89, 81 is to 19. So this k gets cancelled. 81 and 19 are in the lowest form. So this is the ratio of 7a plus 5b is to 8a minus 9b. This is the ratio you have got. Got it? Great. So we can do one more problem here. Exercise problems. If x is to y is equal to 10 is to 3. Why we are taking this k? Because we never know if this ratio is already reduced. Maybe x is to y was 20 is to 6 and got reduced by dividing by 2 and got reduced to 10 is to 3. That's why we need to take a constant value k. We never know k is not 0, k can be 1, 2, 3, any number. That's why we are taking k. X is to y equal to x is to y is 10 is to 3, and we need to find 3x square plus 2y square is to 3x square minus 2y square. 3x square minus 2y square. Okay, so this we need to do same. We'll take x as 10k and y as 3k. If you substitute everything here in this, what you will get, 3 into 10 into 10, 100 k square. So it will become 300k square plus 2 times 9, 18k square is to 3 times again you will get 300k square minus 18k square. So here you get 318k square, here you will get the 282. So this k square gets cancelled. You will be left with 318 is to 282, and this is not in the least form. You can just divide it by 6 and you will get 53 is to 47. This is the lowest form of the ratio. So this is the answer. Got it? Great. So now I have given 2 to 3 some of homework problems. Some of them are easy, some of them are medium. So take a screenshot of that. I'll also put this into description, so you can do the problems, write your answers in the comment box. I will check and I will reply to each and every one. Okay, so this is done now. Today you learned how to compare ratios, arrange several at once, and most importantly combine two ratios into A's to B's to C using both the L.C.M method and also the k-substitution shortcut. In the next video we will flip things around. When given an equation, we will find the hidden ratio inside it, including some sneaky quadratics. So see you there in the next video. Till then, take care, subscribe and like the video.